today we're going to be reviewing how to do pHs and pOHs and go back and forth from concentrations to pH and concentrations to pOH and all that kind of good stuff. So the way this works is there's no points for anything. What you have a chance to do, however, is to see if you understand how to do a calculation. Now, the responders do not allow us. So here we go. Make sure you have your log chart in hand as we continue. Now, when I restart the question like this, that is just a single question, and you should see question 1. Okay, you're not going to see anything more than that. So don't be concerned about it at all. Now, what you need to do at this point in time is take the 4.4, and I'm looking for the exponent that goes right here. Okay? This is an antilog. It is indeed. It's just a number. So what you're doing is you're putting that number in. Now this is one whole number. So all you have to do is put in the number and then go ahead and enter it into your responder. Okay?
So this is just like one exponent.
I'm sorry?
This is just the exponent.
Just the exponent. All we want to get is the exponent here. All right, now let's take a look and see what we're getting for results. I'm seeing about 60% of you getting a 5, and that is the number that we want. And we have 4, 3, 2, and 1. A lot of guessing going on, huh? Okay, where does the number come from? Let's understand that. How do we get 5 from the 4.44? Next largest whole number. So our exponent is going to be 5, and now we're going to take 5 over here, and we're going to do letter B. We're going to have to subtract something, and whatever we subtract, we're going to have to take the antilog of what's in that box, and that is going to give us the number that goes up here. Okay? All right, so we have these interesting rainbow patterns. Okay, let's look at it. What's the number that's going to go right in here? 4.4. Where does that number come from? Right up there. Okay, so that's the number that becomes the 4.4 that we subtract from the 5.00. So we put 0.6 here, 0.6. Now, let's make sure we understand something. I think a lot of you haven't got this clear in your heads yet, so let's see if we can get it cleared up. This is a logarithm. It's not a normal number. This guy is also a logarithm. We started out here with a logarithm, okay? So since that's a logarithm, when we subtract these two guys, we're actually adding them, but because the 4.4 is a minus when we antilog it, okay, it's going to come up with a 0.6 as we add these two guys together, because the 4.40 is a negative number. Now, we look on the log column, the right-hand column in the log chart, and we find the 0.6, and we're kind of lucky on this one. What was the antilog? 4. Okay? So we go back and we put a 4 in here, and this concentration now becomes 4 times 10 to the minus 5. Want to try another one? Yeah. Okay, great. Okay, we're back on recording, and now let's take 6.3 times 10 to the minus 9. All right. 6.3. Oops, can't do that. Whoa. I certainly don't want to do that. It's all right. Thinking is stinky. Okay, 9.5. Okay, there's our new pH. Okay, so we're going to do letter B, or I'm sorry, letter A again. Let's get the exponent first. Okay, it's coming, it's coming. Okay. If you're watching the video, what you want to do at this point in time is pause it and give yourself a chance to do the work before you see the answer, and it will be a lot more meaningful to you. So we're showing here that most people, I'd say about 85% of you, are getting it now. Okay, you understand that we're taking this guy right here and we're making the next highest number, which is a 10.00. Okay, and that's now going to become our exponent of 10. What? Remember, we're doing the minus log. That means we take the log and we change the sign. Okay? So the log of this, when we're taking a log into this area and we are looking at the exponent of 10, what we have done is done the anti-log. And the anti-log is a negative also. Because we used a negative to get there, we got to use a negative to get back. When I say get there, I mean get to the concentration. Getting back is getting to the pH or the pOH, depending on which one we're calculating. Okay, we've got that now. Any questions on how the nines here? Okay, it looks to me like if you put in a 9, you were thinking that we'd reduce this number to the next lowest number, that's whole number. Okay, it's actually rising to the next whole number, not going down. All right, let's go to letter B, and let's figure out what the number is that goes in that little blank over there. And you need to, okay, to put a decimal in, you have to have a number first. So if there is no number before the decimal, you have to put a 0. Okay? So go ahead and put the 0 in, and then your decimals will work. Okay? After we find out what the number should be coming into this position, we then are going to be looking at, after the subtraction, whatever's in the box is going to wind up being anti-log and become our number out front. Okay, so let's take a look at it. And okay, this isn't as bad as it looks because the 3.1 is okay and the 3 is okay. So let's take a look and see what the numbers actually are. What do we put in as the negative to subtract? 9.5. Okay, the 9.5 is going to go in here, and so we get 0, 5, and 0.5. So we look in our log chart on the right-hand column. The log chart is going to read as 0.5, but we don't have a 0.5. It's pretty close to 0.48, but it's actually a little bigger. So when we go off to the left-hand column, we see it's between 3 and 4. So I would call this 3.1 or 3.2. I'd be inclined toward a 3.2, but the 3.1 that we see over here is just fine as we move to the counterclockwise from the 3.2, and the 3.0 even is okay. Okay? So you just did a little bit different. Don't worry, we're going to be doing a lot more of this stuff. So don't be discouraged at all. There's plenty to come.
It's better.
Okay? Now what we're going to do is take the hydrogen ion concentration and we're going to go back to the pH. Okay, this time we're going to take the log of the hydrogen ion concentration, change the sign, and that's going to be our pH. So let's get you started here and go for it. This would be the time when you'd want to pause your recording and try to work this out and then see if you get the right answer when you start back up. What's happening here is you're going to take two logs. You're going to take the log of this guy. You get that right off the chart. And then you're going to take the log of this guy, the 10 to the minus 3, and that's really simple, as you'll see in just a moment. All right. Okay, first off, this guy right here, that becomes our 3.0. Okay, 3.0. Okay, we're just taking whatever that exponent is, that's the number that we're going to start with. Okay, we change the sign. Change sign. Change sign, and we got a 3. Now, this guy we're going to get from our logs, our log chart. Okay, so we're going to look for 8.5. Of course, that's not on the chart. It's nicely spaced directly between 8 and 9. So, what would we say? A 9.2 or a 9.3? 9.3 is good. Or 0.93, not 9.3. 0.93, and we subtract that out. We get 7, 0, and, whoops, not 3, 2. Okay, 2.07. Now, if you had 2.07 or you had 2.08, you did great. Okay? Now, the 7.3s that I'm seeing here, can anybody tell me what got you going towards that number? What did you do wrong? Do you know?
No,
Okay.
the 2.08, still be correct on?
Oh yeah, 2.08 is fine. No problem at all. 2.7, 2.8. Why not? You just estimated it as 9.2 instead of 9.3. That's no big deal. See this digit right here. That's a pure guesswork. You're estimating. Can't be that accurate. So that then becomes our pH. Okay? Want to try another one of those? Okay, let's try another one. Okay, here's your new problem. We are now taking the original hydrogen ion concentration and changing it to another number. We're going through exactly the same process that we just went through. Okay? We first take the minus 9, and that's our top number after we change the sign. Then we look up the 4.5 on the log chart and subtract it, just like we did with the other guy. And then we have to look at the number. Okay? Okay, here we go. Let's take a look now. We're going to review, see what numbers are going to be appropriate. What's our starting number? 9. Okay. This guy right here is going to come down as a 9. Okay, we change sign. And that becomes the first number. So, the next thing is that we want to look at the 4.5, and that's going to be using the log chart. Okay, so log chart, and if you're still having trouble with this, write these little notes down. They'll help you a bunch. Log chart, and we look on the log chart and find the 4.5. Okay, the 4.5 is a number. It's not a log. We're changing it to a log, and we're going to change its sign as well. So the log of 4.5 would be about halfway between 60 and 70. Let's call it our 0.6 and 0.7. So let's call that 0.65. So we're going to subtract the 0.65, and now we have this as a log, and we have this as a log. Originally, they came from the numbers that were in the concentration. So as we subtract out, we get 3 and 8, 8.35. So the 8.35 that I see here and the 8.37, you're just fine. Good job. Okay, and that's almost, I'd say about 70% of the class. If you're in here, I don't know where the 0.35 would come from. I don't know how you got that thing. But that's going to be your final pH. Okay, given those starting numbers. All right? Okay, our next problem, pOH going back to pH. Okay, this is an anti-log again, right? Oh no, it's not an anti-log. What am I saying? No, this is the easy one. Very easy. You don't have to go back to a log or anti-log or anything.
Subtract it from the biggest number. What's up, smart kid?
With this kind of a problem, whether you're going this way or whether you're going back this way, the same formula would be used. Okay? Same formula works. You're always going to be subtracting from 14. Okay, so we got 14, and we're going to subtract the 9.5. That was the given pH, or pOH. And to get to the pH, we just subtract those guys out, and we get 5, or 4, I'm sorry. 4.5, and that is our new pH. Okay? There's just not a whole lot to say about that. It's fairly simple, straightforward. You know, subtract either the pOH or the pH, depending on which one you're given, from 14, and you've got your answer. Okay, we're going to try another problem. And one of the students wants to come up and do it. Oh, some of the smartboard. So go ahead and do it. Go for it.
Oh, we can't do it.
And hold on. Everybody can go right along with her and go for it. Okay? Go for it.
Okay, so first, since it's pOH, we have to subtract it from 14. So either 14 minus 3.4. So it becomes 0.16.
0.60?
No,
Oh, yeah. Yeah, 10.6. Yeah.
Is it
10.6.
No, it's not.
Yeah, it is.
Oh, it is. Okay.
Yeah, you got it. Very good. That's it. Okay, now, we're going to start with 6.1 as the pH. Now, this will be like we did before. Since we're taking the anti-log, we want to find the hydrogen ion concentration. We're going to need an A and a B. And I'll try to keep the color coordination here. So, I'm sorry? We're not doing the wrong thing. Okay, so we're going to start out in letter A. I'm looking for the exponent of the power of 10. So that is your first problem. So 1A, we're trying to find, first of all, the exponent. All right. Now, this is when you want to pause the recording and try to figure it out for yourself before you see the answer. So, what is the hydrogen ion concentration? First part, what is that? Where do we get the number from?
The next highest whole number.
Next highest whole number. So we started out with 6.0 or 6.1, and the next highest whole number is going to be a 7. That's all there is to that guy. All right. Now in letter B. So now we're looking for letter B, which is finding the number out front. Okay, the number out front, which is going to complete the concentration number. This is the time you want to pause the recording so that you can work this out for yourself and then see the answer. So we have all right, let's see how we did. What's our first number that we start with here? 7.0. See, that's our starting number. It's also the exponent of 10. And now what's going to come next? What do we subtract? The pH. Okay, the 6.1 is subtracted from the 7, and we get a 0.9. And now we anti-log 0.9. So we look for 0.9 in the log column, and we see that the anti-log of that, looking over into the left-hand column, is an 8. And so the 8 comes out over here. And so some of you, if you got the 7.9, I would say you did just great. I'm not sure how you got a 6.2, but certainly better than half of you, almost 70%. I don't know, about 66%. Somewhere in there got this, what I would consider correct. Okay, the 7.9 is just a slight rounding difference from the 8.0. Yeah, so it's I don't know why you would try and change that to a, but at any rate, that's fine. And so that's how you do the first part. Now, the second one is that we're going to do is a fairly easy one as well. Okay, let's go ahead and figure this little guy out, and you should be able to work this out pretty quick. Okay, you should pause now so that you try to work this problem before you actually see it worked out, and then you can check your answer in just a second. Okay, for this one, what is the number we start with? 14, yes. 14 minus 6.1, sure. So, and the number that we get is?
7.9.
Yes, it's 7.9.
Yeah.
I'm sorry? How do you do 3? Okay, we'll talk about that in just a minute. But is everybody okay on this, I hope? All right. Now, the last one here that we're going to do is number 3. And for number 3, hold on. What is this number? What is the 7.9? What's 7.9 represent? Good. Okay. So this guy is equal to our pOH. So if that's the pOH, we have to anti-log, because it's a logarithm, we have to anti-log to get back to the hydroxide ion concentration. The reason I put the second question is because that's the step you have to take to be able to get the pOH and do the anti-log of that. Okay, so that's our next step. So what you want to do is we're doing letter A, which is first of all the exponent of 10. And B will be like we did before. And we'll put in the power of 10 after we have a chance to figure out how people are doing with that. If you're looking at this problem and wondering, what do I do now? It's just the same stuff that we've been doing in the first 3 slides. So you may want to roll it back and review, and that way you'll be able to figure out how to do this one. Now's the time to pause your recording and see if you can get this worked out. It is working from number 1. This is working from number 1. But the basis of solving this problem is question number 2. That's the value of the pOH. When we anti-log that, we get the value of the OH concentration. It works the same as if we were doing the pH and trying to find the hydrogen ion concentration. If we anti-log this guy, that's going to give us the pH, but the hydrogen ion concentration. But we're going to anti-log the OH concentration, or the pOH, to get the OH concentration. Good time to pause. Here we go. All right, looking at what we did, I hope we're pretty close. All right, let's try it. What's the first number we put up? The power of 10 is going to be? What? 8. How do we know it's 8? Next highest whole number from the 7.9. So that's where the 8's going to come from. All right? Now, we start with that, right? So we got the 8.00, and now we have to figure out what's going to get subtracted. Get this number, look at our log table, and anti-log to this. Okay, good time to pause, and let's see if you can work this out on your own. Okay, now that we have the results, let's look at the 8.0. We know that that came from the exponent of 10, which was the next highest number from the 7.9. And so the number we're going to subtract here is the 7.90, because that was the pOH. And when you subtract that out, we get a 0.10. Now that 0.10 is what we have to look up on our log chart. When we look at the log chart, on the right-hand column, those are logarithms, because this guy, and this guy are all logs. So, at the end, we now look at that, and it's between the 0.00 and the 0.30. It's about 1/3 of the way. So, you could call this a 3, or you could call it a 4, and the power of 10 would be 10 to the minus 8, and that would be the concentration of the hydroxide ion, okay, which is about, well, when you add up the powers of 10 for the concentration of the hydroxide ion and the concentration of the hydrogen ion up here that we wound up getting, you will notice that the guys come very close to 14. They actually add up to 15 if you multiply the powers of 10. 10 to the minus 7 times 10 to the minus 8 here. Okay, those guys are going to add up to 10 to the minus 15. And then when you add up the numbers of 8 and 3, you come up pretty close to 10. And at 10, you have to move the decimal back a little bit, and that would be 10 to the minus 14, which is what it should be when you multiply the concentrations by each other. So there you have it. I hope you find this helpful, and thank you for watching.